Okay, and what is that? That's the response. The end of an actual homeostatic process is a response, which is to do what? Increase that calcium. Go against, oppose the stimulus that originally started the whole process. Right, so that makes sense, and that's a negative feedback process when the response opposes the stimulus. Okay, in this particular case, hypocalcemia, the stimulus is opposed by increasing calcium. All right, and so now we bring our calcium level back up to the 10 milligram, and everybody's okay again. This happens constantly in your body, and that's why you don't have to worry about a thing. And that's the beauty of homeostasis. Okay? But that's calcium homeostasis there. Your parathyroid hormone doesn't just go to osteoclast, he also goes to the kidney and makes sure that calcium isn't urinated out. So that brings in even more calcium to your body as well. So two places the osteoclast goes to is the bone and the kidney. Our more extensive discussion on kidney, though, will be in A&P 2. All right, very good. All right, so, but again, what does this system rely upon? Heavily relies upon the function of what? Mineral reservoir of the bone. If there was no reservoir of calcium, then all your osteoclasts are going to do are take out too much calcium, and now your bone no longer serves to be a what? Structural framework, protect. And so everything falls when you don't have the right amount of calcium in bone. All right. So mineral reservoir is what calcium homeostasis relies upon. That function, which is called mineral reservoir. Okay. Very good. Don't forget for our women, when you get to menopause at around the age of 48 to 52 years old or so, you're going to have a decreased amount of what? Estrogen. That's what menopause is. And as we stated in class, estrogen, just like testosterone, is a hormone that increases activity of osteoblasts. Right there at that epiphyseal plate, you have growth factors. A big one is sex hormones, which are your testosterone for men, estrogen for women. However, estrogen is obviously stronger as it relates to increasing osteoblast activity. That's why women stop growing, like we mentioned in class, a little bit earlier than men. They stop growing at around the age of 18. We stop growing at men, stop growing at the age of 21. But there are other growth factors as well that work at the epiphyseal plate, such as vitamins, vitamin A, vitamin B12. And you also have other hormones like growth hormone and insulin like growth factor, thyroid hormone from the thyroid gland that does that too. So there are actual growth factors, if you will, that help you grow. But that just basically underlies what a major issue menopause is for women when we're talking about estrogen no longer around. So then your osteoblasts are going to be outdone, if you will, by the osteoclasts. So now we have an imbalance. Remember we talked about bone remodeling was the balance between osteoblasts and osteoclasts? Well, when osteoclasts win, they're going to cause a problem because now you have too much calcium coming out of bone, and now you lose that feature here related to it being all of these things we talked about with the structural framework, protecting, what have you, and then we can get fractures now, right? So a complication of menopause is that incredibly low amount of calcium deposited in bone, and now you're susceptible to fractures and what have you. When that bone becomes softer, if you will, because there's less minerals in it, that's what we call osteoporosis. All right, and so that's a complication of the menopause, osteoporosis. Okay. All right, so be careful with that, and that's why later on when you're in menopause, you might have to use supplements. Vitamin D increases the amount of calcium that can go back into your body when you're eating. So you have more of that, and you might use some forms of a different type of, if you will, a drug that acts like estrogen as well, or even estrogen itself. All right, so that's the different drugs and treatments for your complication of osteoporosis during menopause, which makes sense, right? But yes, mineral storage, that mineral reservoir function of bone, highly important as it relates to you making sure you have the right amount of calcium in blood. Very good, very good. All right, so now your actual next function is interesting as well. Not a major function for it, but since later on in your life, that medullary cavity and long bone used to be what we call red bone marrow, but what does it turn into? It turns into yellow bone marrow, which is basically just means it's adipose tissue in there. That's the color of adipose tissue. And so therefore, what's in adipose tissue? Well, plenty of what? Triglycerides. That's the storage form of lipid in our body so that we can get energy whenever we want. Most of it, obviously, triglycerides are in adipose tissue, or subcutaneous tissue, which we talked about in chapter 5. But we're going to have some also in your actual yellow bone marrow. And so therefore, your bone helps out quite a little bit as well as it relates to having a storage for triglycerides whenever your body needs energy. But that's a minor function, not a major one, all right? And then we have hemopoiesis, which means the production of blood. We wouldn't have thought this hard material is the place where blood comes from. The blood cells in your body come from bone. Which portion though? Make sure we remember that it's not compact bone. Compact bone, which has osteons, those actual networks of osteocytes that have canaliculi between them so they can get their oxygen and nutrients in this hard-like material. That's called osteons. Osteons are with compact bone. And what is that? The outer portion of bone. In bone, in all 206 bones of your body, the inner portion of bone is what we call spongy bone. That's where trabeculae is. That's where those spaces are. And in those spaces, we have reticular connective tissue, that loose type of connective tissue. You have jelly in there. That's the consistency, right, of loose connective tissue. Jelly-like material, and that is going to be in spaces of spongy bone. This more softer type of bone in the inside of bone. And that's where you're going to have, where we have red bone marrow. Okay, why is it red? Because the most abundant cell, as we'll come across that in chapter 19, when we talk about blood, the most abundant cell of all your blood cells. What are your blood cells? Red blood cells, white blood cells, and these cell fragments called platelets. Red blood cells are the highest number. So that's why your blood looks red. Okay, that's why your blood looks red, because you have more red blood cells than any of the other cells. And that's why we call this the place where all of those blood cells are, red bone marrow. Obviously, we have more red blood cells than the white blood cells in platelets. All right, so that's why we call it red bone marrow. Like I said, though, you did have in that medullary cavity of long bone, you did have red bone marrow. But as you grew up older and by the time of adolescence, you only have yellow bone marrow in the medullary cavity. But that's why we have this function of triglyceride storage, adipose tissue there. But in all of your bones in the middle of bones, you have what we call red bone marrow. And that's where blood cell production occurs. And that's what hemopoiesis means, blood cell production. So blood comes from bone, okay? So this is what we're thinking about, right? When someone has bone issues, well, things aren't what? There's no structural framework. We don't have good support of actual tissues. We don't have good protection of organs, okay? We might not have good movement, right? There might be an issue with the amount of calcium you have in blood, right? All right, that's what the main function of mineral reservoir really help with, right? A person with bone issues, minor issue would be the fact that they don't have enough what? Triglyceride storage. Because don't forget, most of that is where? Deep to the skin in the subcutaneous tissue. But so not so much of when you're thinking of a patient's issues with bones is it going to be related to this function here with triglyceride storage. But big time issues. Somebody with a problem with bone, we're very concerned about blood. Blood is our distributing means of delivering everything to different parts of the body. So hemopoiesis, that is a huge issue. Your alarm bell in your brain should go off when you have a patient that has bone issues. You say, is their blood okay? Is their blood okay? All right? But yes, even when someone doesn't have bone issues and they're real low in energy, don't forget red blood cells are basically what delivers oxygen to tissue. So whenever you're low in energy, we're really concerned about blood cells. So one of the things we check later on in our actual workup would be bone, right? That might be problems right where the source is, where blood cells come from as it relates to if someone has problems with blood. So we check the bone. That's why we do what we call a bone marrow biopsy. That's all that is taking out some of that reticular connective tissue, which is called red bone marrow, taking it out. And then we look at it on the slide and on the microscope. We see, oh, it might be some issues with where the blood cells came from. And that's a good way in checking if you have a blood disorder. All right, so yes, all of these are very important. Make sure when we go through different systems, the functions are very important. Understand that when this system is something's wrong with it, you go to your functions and say, oh, this is what the patient's going to have problems with. These types of functions. And that's very good, okay? Very good stuff.